Welcome back. Today we're going to be talking about solving systems of equations. Now, there are many ways to solve a system of equations. What we're going to talk about today is by graphing. We're going to graph our lines out. We're going to be talking about linear equations today. Graphing our lines out and seeing where they meet. We can use two different forms of algebra, either substitution or linear combination, to solve it that way. We can use matrices, which we will either learn later on this year or maybe even to next year. And there's another way. We can always guess, make a most educated guess. But trust me, that is the least efficient. We definitely don't want to worry about guessing. So, when we're talking about solving a system of linear equations, it has a lot of applications. Businesses use this daily, finding break-even points, finding out the optimal price to sell a product at so they can maximize their profit. We use it in personal life to balance our budget, make sure our salaries that we make at our jobs can pay for our expenses, pay for our house, our car, our vacations, our kids' tuition, things like that. So to start off with, there are three answers you can get by solving a system of equations. Please pay attention to this, because I guarantee this happens every year. Someone will give one of these an answer that's not here. So we're graphing two lines, or we're working with two linear equations. The most common solution is where we have one unique solution. Now, if you're thinking about graphing two lines, this is where we would have two lines and they meet. Make an X, they could be like this, but somewhere they will meet. And the answer is where they cross. It'll be an ordered pair, an X and a Y value. So the lines will cross only one time. They will never cross 2, 3, 4, 5, 6, 7 times. There's a multiple choice question on the ACT that says, how many solutions will this have? One of the answers is 2. People will put 2. Don't do it. It's not possible. We have one solution, and they'll cross. The thing to remember on our line, they will always have different slopes. All right? Different slopes, 1/2 and 1/3, 2/9 and -15, just different. The next possible solution is where we have no solutions. Now this is going to be where our lines never cross. Maybe something like this, or something like this, something like this, something like this. These lines will never cross because they are parallel. Now if you remember back from geometry, parallel lines have the same slopes. So if you can see that it's y equals 3/4 x plus 10 and y equals 3/4 x plus 15, you automatically know it has no solution because the slopes are the same. They will also have different y-intercepts to look at, which is going to be a little bit different than our next possibility. So definitely need different y-intercepts. And our last option is if we have infinite or many solutions to a system. This is where both equations end up being the exact same line. Just might be different coefficients and a different constant. It will be a line that if we graph one of them, it's going to be right on top of the other, which means all the points along this line are possible. And it goes on forever, so it's infinite. You could pick many, many different solutions. So this will tell us that these two lines have the same slopes and they have the same y-intercepts. Now the best thing about graphing is that it shows us a picture. Many times we like to see pictures. Many of us, including myself, would rather watch the movie than read the book. Many of us would like to look at a graph than look at numbers. So that's the best thing. The biggest con to it is that sometimes it's not accurate. Sometimes we have to kind of guess at what our answer is. So how this works is we're given two lines, and this is our problem number 1. Y equals 2x minus 1, and y equals 1/2 x plus 2. Now looking at this, I have a slope of 2 and a slope of 1/2. This automatically tells me that I'm going to have one unique solution. So by graphing this, I'll start with the green graph here. I start on my y-intercept of 2. My slope is 1/2. Up 1 over 2. Up 1 over 2. I'm not going to draw my line quite yet. My other line is 2x minus 1. I'm starting down here at 1. That's my y-intercept. My slope is up 2 over 1. Up 2 over 1. And look what happens. This is going to intersect right there. There's my black line. Here's my green line. And it's going to intersect at that point. Now when we do these, hopefully they kind of cross at the integers where the graphs and the grids kind of intersect. And we can see this point is 2, 3. And that's our answer. There's our unique solution as an ordered pair. 2, 3. So let's look at another one. Let's look at number 2. Number 2, we have y equals negative x plus 1. And we have y equals 1/3 x minus 3. Again, I'll start with my green equation here that I wrote down. Start with my y-intercept of negative 3. Now I'm going to go, my slope is 1/3. Up 1 over 3. Up 1 over 3. Whoop, a little more. 1. And you see I kind of had to change it up because I wasn't being perfect on my graph. Graph the other point. I'm up 1. And now this slope is a negative 1. Down 1. Down 1 over 1. And I see that it crosses here. It kind of overlaps. That's what I'm hoping for. So my answer here is 3, negative 2, where those points intersect. Now we're going to look at one that's a little bit different, looking at number 3. So those first two problems ended up with one unique solution because they had different slopes. Now with number 3, these numbers are not given in slope-intercept form. The first equation is 2x plus 4y equals 8. The other equation is x plus 2y equals 4. So again, it makes it kind of hard to graph it in this form. So I'm going to put it in slope-intercept form. I'm going to add negative x plus 4 over here, and to divide everything by 2. So my equation is negative 1/2 x minus 2. Start at negative 2, down 1, over 2, down 1, over 2. You can see my line's going to be going in that negative direction. The green equation, I'm going to add negative 2x to both sides. I now have, I'm going to kind of bring this up here, 4y equals negative 2x plus 8. Just adding the opposites. Divide everything by 4. I end up with y equals negative 1/2 x. And I screwed. This was supposed to be a +4. That's a +2, so I graphed this wrong. Sorry about that. But if you notice, same slope, negative 1/2, same y-intercept, 2. It is the same exact line. So this, because it's the same line, has many solutions. Now I'm going to kind of skip ahead to number 5. So number 5, one of the equations is y equals negative 2/3 x plus 5. And the other equation is 2x plus 3y equals 3. Now, this first equation is in slope-intercept form. We can graph this. The second one is not. We have to change it. So I'm going to add negative 2x to both sides. End up with 3y equals negative 2x plus 3. Divide by 3. And I'm left with y equals negative 2/3 x plus 1. Now if you notice, slope of negative 2/3, slope of negative 2/3. Different y-intercepts. So if we go back to that little chart we did, these should be parallel lines. I went ahead and kind of used the graph, and this is what the answers would be. Okay, the bottom one is negative 2/3 x plus 1. The top one is negative 2/3 x plus 5. And there would be our solution. And we can see that they never cross, so this would be an answer that has no solution. So to conclude, in order to graph these, the easiest way to do is to first of all make sure both equations are in slope-intercept form, so we can start with the y-intercept and then graph the slopes. See where they cross, and that's your answer. Right. Hopefully this helps. Remember, this is best if you're just kind of looking to guesstimate your answer. Precision we'll worry about in the next lesson when we talk about substitution and linear combination. Okay. Have a great night, guys.